So Python is known for its large, diverse libraries. As one of the features of Python is that it has many libraries, like libraries, whatever you can think of. There are libraries so that you can even make your normal file or images converted into a PDF. You don't need to upload it online to convert it to a PDF. You can simply run few lines of code and convert your file or image or merge two PDF into a PDF. So Python is known for its variety of libraries, and there are few libraries which helps in mathematical computation, scientific computation, data processing. Like if there is a tabular data that can be imported into Python and that can be looked up. That data contains some garbage value, of that data contains some empty values, or if data has some values which are not required, or to if that data contains the null values, to fill that null values with some information so that that data can be plotted if it's need to be plotted into something. So there are many libraries which are used, and there are few libraries which are which are the basics of the machine learning, and which you will get to know in the upcoming videos. So one such library is Numpy. So Numpy is for array process. So there is one question everybody thinks, that we have a list which is like array only, which contains a list of data type. So why we are having unspecific library for array if we have list? So to answer that question, the list can have multiple data types. The array contains one such data types. List and what happens? NumPy uses less memory. It is faster than list, and it is much more convenient than a list. That is why if you want to make if you want something for scientific numerical calculation, if you want a list of integer, or if you want a list where we want to do numerical calculation, linear algebra, Fourier transformation, or if you want to imply matrices, we use NumPy instead of list. So we can have n dimensions of array using NumPy. The NumPy library is based on C++, and we can use linear algebra, Fourier transformation, and random number. There are many uses of NumPy. So to import NumPy, there is a library known as NumPy only, and we write import NumPy as NumPy. So I will write it, import NumPy as NumPy. I will run it. If that library is present in your software, whatever software you are using, so if that library is there with your Python, it will not show any error. If that library is not present, you need to install it using pip. Okay, so I will make a simple array. This is a variable. A is equal to np dot array, and a simple array of integer 2 comma 3 comma 4 comma 1. If okay, first I'll make of integer. Okay, I'm printing a, it's an array. This, what if I make an array with some integer and some, sorry, array with some integer and some float variables, values 1 comma 2 comma 1.1, 1.1 comma 2.1 comma 4. Okay, I will run it. It's working. Let's see what that array is now. So you can see, because we have heterogeneous value in array, so the integer was automatically converted into float. So you can see I did not write 1 point, but it is now 1 point. Okay, so it was automatically printed in a form of sorry, it was automatically converted to float. Okay, now what if I have np c is equal to np dot array. uh, okay, so I have 1 comma 2 comma Python. So you can see I've told you that array contains heterogeneous elements, but I wrote a string with integers. So what will happen? It's still working. It didn't throw any error, but what will happen? I'll print C, and you can see that it changed the integer into string automatically because it has all the elements as heterogeneous, same elements, heterogeneous element. Okay, I will do type of C. So it was numpy as ND array. Okay, so now we can have any number of array. So zero array or a single value is called a scalar value in numpy. Then we have a 1D array, a single array, and then 2D array, which is a matrix, right? And then ND array, we can have any dimensions of array. So I will show you how to make a single array. Okay, so I'm taking a is equal to np dot array. Okay, so I will write a value. I will have written 12. Enter a. So this is array 12. Then I will write, if I write type a, showing numpy.nd array, and then there is a method which is ndim to find the dimensions. So if I write a dot ndim, so it's showing 0, so the dimension of this value is 0. Okay, now I will show you how the 1D array is made. So I'm copying this only, this example only. So to make a one to write a 1D array, I write a single list. Okay, so I have, so this array was made. I have shift entered. This array was made. I will print b. I will print type b. So it's an array, and I will print b dot ndim. So it's one dimension array. Okay, then we have a two dimension array, which is n into n array. Okay, to have so I will copy this example only. So we have one bracket for one row. This is one row. Okay, one row, so one row with 3 columns, and this is 2 rows with this second row with 3 columns. Okay, and then like one column, one row in one list, another row in another list, and one bracket for the whole list. I will Then I will print this, so you can see it's in form of n into n, right? So this is one row, one column. If I would have wanted 3 rows, like a 3 into 3 matrix, this is 2 into 3 matrix. What if I wanted a 3 into 3 matrix? So I will write comma bracket 6 7 comma 8 comma 9, and I will run it. So now you can see it's a 3 into 3 matrix. So first row, the second row, and this is the third row. So I will write c dot ndim, and you can see it's a 2 dimension array. So now the example of a 3D array. Control C, Control V. Okay, so I will run it, and I will run the array. So what is happening? This is the first plane, and this is second plane, and the third plane is 0 0 0. What if I add another plane? Okay, so we can n number of plane in this 3D array. So if I add a plane, and wait, okay, so another 1 comma 2 comma 3, and 1 comma 2 comma 3. I will run it and run it, and you can see this is a third plane added to it. So this is our 3D array. I will do n dot ndim. Okay, and this is the array 3, array of 3 dimensions. So I will write e. I have to make another array. So e is equal to np dot array, and then I will write 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. Okay, this is my 1D array, comma n dmin. The attribute is n dmin is equal to 3. Okay, now, okay, I forgot n. I said n dmin, but I forgot n to write. So now I will print e, and this was simply converted into a 3D array. So this is the first plane of the array. Like, this was not divided into the arrays. This was not divided into 3D array, or the single line was converted into a, this will be single plane, and the whole, the dimension of this array e will be dot nm will be 3. Okay, so this is how you can make dimensions, n dimensions of array, by writing n dmin is equal to number of dimension you want. So if I want to print what is the data type in the array, so I will add e dot d type, and this is integer 32. Okay, so as you can see here, we have np.float 64. Also, we can specify also that what type of I want float 32 or float 64. So 32 will take 32 bits, and 64 will take 64 bits. So I can specify what type of data type I want in my array. So here I took 42, which is an integer, but I wrote data type is equal to np.float64, and was converted into 42.0 of float 64 integer. Okay, so where you can see, this is an example to make a 4D array. So I will copy this, and I will paste this, and now I will run arr. So this is the array, and arr dot ndim. So this is 4. The answer here is 4. Next we have arrange. So what does arrange do? So the arrange function gives the list of integer, like the range function we have, which also gives the list of integer. So we can make an array. So if you want to make array is equal to np dot range bracket 2 comma 20. We can also include slicing that we had in arrange. So I will do slicing of 3, and I will run it. Then AR is this, it's an array. Okay, and if I want to, and if I want to see the dimension, I will write AR dot ndim, and the dimension is 1. Okay, then we have indexing in Numpy. So the indexing for 1D array is simple. So this is also 1D array, this AR. So AR is the 1D array. So for 1D array, the indexing is simple. If I want to print the first element, I will write 0. Okay, if I want to print the fourth element, I will write 3, because indexing starts from 0. It's a 0 based indexing, so it starts from 0. So 0 1 2 3 4, I wanted the fourth element, so I wrote 3 AR3, and it was 11. Now to access our 2D array. So in a 2D array, so first I will take an example of 2D array. So we had C as a 2D array. So first I will print C here. So this is a 2D array. Okay, now to access 2D array, we write in a form of I comma j, I representing the row and j representing the column. So if I want to print the second this 8, so this is the um, third sorry, this is the third row and the second column, but since it's a zero based indexing, so it will be 2 comma, so it will be 2 comma 1. So it is the second column and third row, 2 comma 1, and it was 8. Okay, because it's a zero based indexing, so the first index, the first element, which is 1, will be at 0 comma 0. So at 0 comma 0 we have the first element I, 1. Okay, so if I want to do indexing in 3D array, so 3D array, D is a 3D array, so I will first print D here. So I think so to access the to 3D array, if I write 0 comma 0, so what will happen? It will print 1 2 3. So it's printing the 0th uh, row and the whole column. If I add 0 comma 0 comma 0, what it will do, it will print the first element. So this is the 0th row, 0th column and the 0th element. So if I write 0 comma 1, so what will it do? It will print 4 5 6. So what is happening? This is the this is the 0 row, this is the first row, and this is the second row. So 0 1 2. Now this is the now this is the 0th column in this, and this is the first column, this is 0 column, this is first column, this is 0 column, this is first column. If I write 1 comma 1, so it will print this 14 15 and 16. Okay, and if I want to print this 15th element, so I will write 1 comma 1 comma, this will be 0 1, so this will be 1 comma 1 comma 1. So if I write this, it will be 1 comma 1 comma 1 will be 15. So this is the indexing. So this is how our indexing is done in Numpy. Okay, next we have slicing in Numpy. So slicing in array is same as slicing we had in list or string. So I will take the 1D array, which is AR. So I will print the AR here. So I want to do slicing. So AR 0 to third element, which will be 2 5 8. Reverse of this array will be space colon minus 1. So the slicing which we did in list, tuple or string, that is exactly same slicing for this concept slicing in array. Okay, then if I want to do slicing in 2D array, so I had C as a 2D array. So the C is a 2D array. So if I want to, okay, so C, okay, so 1 comma, so the index 1 comma whatever I want to do, so 1 comma minus 1. Okay, so I want to reverse the elements in the row. For the 1 will be 0 1 2, so this will be the row. Okay, so 6 5 4. Okay, so first we mention the row, and then what slicing we want to do, we mention that. Okay, so if I want to do if I want to print element first and 2 in row second, so 2 comma 1 space comma 2. Okay, so this will print from 0 to index 1, so it printed 7 and 8. Okay, so see, So let's see if I apply slicing in this column. In the column, so if I did space colon colon minus 1, okay, colon colon minus 1, comma, if I take right 2, so what will happen? So 7 9 6 3. So it was row, so it took 0 1 2, it took the third column and that reverse of it. Okay, if I similarly if I took the second row, sorry, the second column, so I will write 1, and we have reverse of this, so it is 2 5 3, and now it is 8 5 2. If I don't write anything, so it's colon space colon space colon not space. Okay, so it's printing 2 5 3 of this row. Then we have next we have size. So size tell you the number of elements in an array. So c dot size, we have 9 elements, 1 2 3 4 5 6 7 8 9. Okay, then d comma size, d is our 3D array. So d comma size, we have 18 elements. Like, let's check. So it's 1 2 3 6 6 1 the 6 12 6 3 the 18. So we have 18 elements. So size give you the number of elements inside an array. Okay, then we have this, we had one more array. So we had this AR. So let's see the size of AR dot size. So it's 6, it contains 6 elements. So 1 2 3 4 5 6. So size give you the number of elements in a list. Then we have another, we can say a method, or a method which returns the number of elements and dimensions. Okay, so it gives you the dimension in a form. So, and it returns a tuple. So for 42, it's because it's single element and the dimension is 0, it's returning space. Okay, so a dot shape. So tuple object is not callable. A was not a tuple. So A was not a tuple. So I will run this again. Okay, I will run this again. So it's a 1D array. So a dot shape should be, okay, sorry, it does not contain a bracket. So a dot shape is 4 comma 0, because it's a 1D array with 4 elements. Okay, so for 1D array, it's showing you the size 4 comma this nothing. So that means it has 4 elements. So for C dot shape, so it's a 3 into 3 matrix. It's not showing how many values, but it's showing that it's a 3 into 3 matrix. So D dot shape, so it's 3 2 and 3. So it contains, it's a 3 dimension, it contains 3. So 1 2 3, then 3 columns. So the the axis 0, the x-axis is 3, then it's the one axis is 2, and the second axis contains 3 elements. Okay, so these are the further examples. Okay, then we have reshape. So what does reshape do? Reshape, if I want to change the shape of an array, if I want to convert a 1D array to a 2D array, or 2D array to 1D array, I write reshape. So what happened? Reshape returns the new element, new array. So if I have this 1D array, so I have a AR array. So this is the AR array. I want to convert it into a 2D array. Okay. So what I will do is, so AR dot reshape, and in bracket, I will write the values. So it will be a 2 into 3, because it has 6 elements. It will be a 2 into 3 element. So it was a 2 into 3. What if would have happened if I would have written 3 comma 3? So cannot reshape of size 6 into shape 6. So it is size 6 and this contains 3 into 3 9 elements. So it can't adjust into that. Okay, what would have if it was 1 comma 3? Same shape 6 and there are 3 values, only 3 values accommodated in 1 comma 3. So I will write 2 comma 3 and which can accommodate 3 values. Okay, so what if I have this 2D array C and I want to convert it into a 1D array? So this is my C and I want to convert it into a 1D array. So I have two options. First, I can do C dot reshape and -1. This will convert it into a 1D array. So it's a 1D array. So what is happening, because I'm not saving the C is equal to, I'm not doing C is equal to C dot reshape. So it's not changing the value of C. This is returning a new array. So I can save it into a variable or I can simply print it. So d dot reshape. Now if I'll print d, it's the 1D array. And if I print C, it will still be a 2D array. So what if okay, so I said there are two methods. One is reshape and other is a method reval. So I will write C dot reval. Okay, bracket. It has an object weight. Okay, so np dot reval C. What if I wrote, okay, there is a spelling mistake. So spelling is reveal. So RAVEL. So I was writing a wrong spelling. So this 2D array was converted into a 1D array. Okay. So we have examples here of this. You can look into it. Then we have few functions to make array. We have function to make all zeros, all one, all the full array with where I can give the dimension and the value, and then identity matrix. So I will copy this. So if I want to make an array of all zero value, we have this in when we are solving matrices. So this is an array 3 into 3 of 0 value. So this is 3 comma 2 array of 0 values. So if I wanted for all these, all ones, okay. So we have this, okay, 1 comma 1. It's taking float. Now this is, then we have full, then as we have a method full. So what happened in full, this is np dot once, it return once, and we have np dot full, which returns the this is the dimension and this is the values. Okay, if I would have taken a third 3D, so let's see will it work in a 3D or not. Okay, first I will show you in 2D. So 3 comma 3 and comma 4, so it has 4 in 3 comma 3 matrix. So sorry, print C. So it is 4 in 3 comma 3 matrix. Okay, so what if I would have added another shape dimension into it, 3 comma 3 comma 2. Let's see if it works or not. And it works. So now it's a 3 into 3 matrix in a 3D. So if I write C comma n dim, so it's a 3-dimension array. Then we have a method line space which returns the n number, which is this. The method is np.linespace start comma n comma n. So it returns the the number of n numbers between the start and end, and both are included. So if I want, and the values are linearly separable, that's why this is linspace. Okay, these values are linearly separable. So if I want to write np dot uh, linspace, so these are linearly separable, which means the value between all these are same. So if I want to print from 1 comma 100 and I want 10 values, okay, so we all know, so so this will be linearly separable values from 1 comma 10, 1 comma 100, and 10 value 10 numbers between 1 comma 100. So it has 1, 12, 23. Okay, if I would have written 10 comma 100 and 10 values, okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is like, you can see that it's really separable, like it is visual. Okay, so that what happens, so you can see, so every number has a difference of 10, so 10 values. So so this is linearly separable. So if I write 100 between 10 100, so it will return 100 values which are linearly separable between 100 and 10 and 100, and both 10 and 100 is included. Okay, so you can see 10, 10.9, 11.81. So this is linearly separable, and these are 100 values. So if I write, if I save it into a variable f, and if I write f dot, if I write f dot shape, so it is saying that it's a 1D array with 100 values. Okay, then we have operations on single array. We can have a 1D array on a single array. Okay, so sorry, in a 2D array which is single. So I have array C. Okay, I have a C array which is now converted into a, so I want this uh 3D. Okay, I want this array. It's a 3D, not 3D array, it's a 2D array which is 3 into 3 matrix. So I have rerun it. I will copy this from here. Control C, and I will paste it. Okay, so now I want to do perform operation in this. I would have done in this also, but it is like easier to understand what is happening here. So that's why. So if I want to find, so we have 4 operations: min, max, sum, and square root. So if I want to find minimum maximum, so c dot min will give the minimum in this array, which is 1. C dot max will return the maximum in this array, which is 9. Then C dot sum, okay, it's returning 45, which is the sum of this whole matrix. Then C dot sum axis is equal to 1 will return, sorry, axis is equal to 0 will return for each column. So column 1 2 3, so 7, 11 plus 1 12, 8 plus 5 13 plus 2 15, 9 plus 6 plus 3 15 plus 3 18. So this column wise, if I wrote x is equal to 1, it will be, so it will be like this. So 3 plus 2 plus 1 6, 4 plus 5 plus 6 15, and then 7 plus 8 plus 9 24, which is here. Okay, and if I write x is equal to 2, it will throw an error because there is no x is 2 here. Okay, so we have only x is 1 and 0 because it is a 2D array. Okay, so this is it do, it will return the square root of each value. So 1 square root is 1, 2 is 1.4, 3 is 1.73, 4 is 2, 5 is 2.23, 6 is 2.44, 7 is this, 8 is 2.82, and 9 is 3. So it will return the square root of individual array. Then we have vector operations. So vector are single dimension array, and we have subtraction, addition, subtraction, multiplication between these array. Okay, so I have n. So I will make two array. Z is equal to, okay. So I will have array. So I will use 2. So I will print Z, and then y is equal to np dot range 11 comma 20 comma 2. So I have these two array z and y. Okay, so what will happen if I add those two array z plus y? So it is adding each value z minus y, okay, and then y minus z, 10 10 10, the difference is 10, then y into z, so it's multiplying each value. So 1 into 11, 13 into 3, 15 into 5. Okay, what if I did n z dot, okay, so what if I do, okay, so z dot y. So it has done a dot product. So it has multiplied and added like an array. 1 11, it was 11 plus. So the dot product is, so it, what is happening? It is the z dot y. So it is adding 11 plus 39 plus 75 plus 119 plus 171. So what is happening? It is multiplying. So multiplication of z and y. 11, it's 11 into 1 plus 13 into 3 plus 15 into 5 plus 17 into 7 plus 19 into 9. So that is a dot product. Okay. Then division, y divided by z. So it is 11 7, okay, and z divided by y will give a decimal value. Okay, then we have an inner product, that is dot, which is the multiple matrix multiplication, right? So I've told you how does that work. Then matrix operation, I have a it's a 2D array. Okay, so I will copy this, Control C, and I will copy this. Okay, then addition is np dot add b comma c. Okay, what if I did a plus b? Sorry, it's b plus c. So it's still adding. So we can do b plus c, or we can do np dot add. Okay, then so okay, so there is this error. So the error is, it's the shape of array should be same. Okay, so if so here I tried adding a 2D array with a 1D array and it's throwing an error. Okay, so z plus c. So operand, so can't be with together with shapes 5 comma 1 and 2 comma 2. So the shape in addition should be same. Then we have matrix multiplication. So we can do matrix multiplication two types, one using dot and another using matmul, which will give same value. Okay, and what if I did, first I will show you what if I did b into c. So it's multiplying each value 5 into 5. Okay, first I will print b here. Okay, this is array b and this is array c. Okay, so b into c. So 5 into 5, 5 into 1, 6 into 2, 7 into 3, 8 into 4. Okay, then we have dot product np dot v comma c. So what is happening? It's multiplying uh, this with this with this, and giving you the value. Okay, then we have matmul to give matrix multiplication np dot matmul c comma b. So I've changed the value. Even the answer is changed. If np dot matmul b comma c. So the answer for dot product and matmul is same. So we can use either of these two methods. Then we have transpose. We all know what transpose do. It switch rows and column. So I will take the array. Okay, so what will I do? I will take this array. I will copy this array from here again. Control C. This is a 3 into 3 2D array. Now I will use transpose. Okay, so np dot trans. Okay, first I will print the C. np dot transpose, then C. Okay, so what it did, the 159 was kept same, but the values of rows and column was changed. Okay, we all know how transpose work. Okay, then this is the inner and dot multiplication of A and B. So then we have a rank. So ranks give you the highest order of non-zero matrix. Okay, so I will copy this np dot linear rank and control V. So I have a matrix Z. Okay, so first I will see what's the rank. Rank is 1. Okay, so this is the Z. Z and Y was 1D array. Then I have this matrix B. Okay, so if I'll change write it to B, so it's 2. Okay, then next we have eigenvalues and eigenvector and eigenvalue. So we all know what does eigenvector and eigenvalue in matrix is. So if we are doing linear algebra, so for a scalar is called an eigenvalue of A. A is the matrix of n into n matrix. If there is a non-zero vector x, it's satisfying the following equation. So to find the eigenvalue and eigenvector, so this is w comma v. So one is values and another one is vector, and np dot lineang dot eig is for eigenvalue and d. So this will return the value w, which is the eigenvalues, and vector, which is the eigenvector. Okay, then we have a determinant. Determinant of a square matrix can be calculated using det function. So I will find the determinant of this. So the method is np dot linear algebra dot this is for linear algebra. Okay, np dot lineang dot det, and d is the name of the matrix, and this was the determinant of this value determinant. So the next we have the logs function, the logs in Numpy. So we can find log. So okay, I will make this array A. So this is array 304 4 raised to power 4 value array. So now I have to find log e, log base to power e, log base to power 2, and log base to power n. Okay, so np dot log will give the value log e. Okay, of each value. Okay, np dot log 2 will give for base 2. Okay, and then np dot log 10 will give for base 10. So these are the value. Okay, and then we can have even for a scalar value. So np dot log 10 for 10 will be 1. Okay, and for 100 will be 10, sorry 2, so it was 2. Okay, and we can find different documentation for NumPy in this link for different mathematical function and for all the documentation. Then we have trigonometric functions also. So if I have this array for angle, so these are the array and these each value are the angle. Okay, so I will find sine. I will just show you for the sine and rest I think everybody will able to understand. So NumPy gives has trigonometric function which return ratio for the given angle in radian. So this is an angle in radian. Okay, this is not angle in degree. This is 30 radian. So np dot sine. So this is the angle, okay, 0, 30, 45. And here I'm doing, I'm writing a into, so it's a into np dot pi by 30. So it's converting into a value. Okay, so I will write angle here. I will write a here and I will convert this into a. So a into np by pi divided by 80. So what is happening? It's converting this value in degree into radian and finding you the sine value. Okay, so these are the value in radian for these given angles. So if I have np dot cos, np dot cos a star np dot pi. Here it's calculating into radian, converting the angle into radian, 180. So this is the value for each angle. Similarly, we have tan. Okay, then statistic using NumPy. So if I have a data of array, which is a random, this is the data, and I want to find the mean, median, mode, mean, median, and variance and standard deviation. Okay, so np dot mean of data underscore n. Okay, this is the mean of this whole value. Everybody, I think everybody is familiar what is mean. Then median is 4.0. Then variance, then standard deviation. Your standard deviation is the square root. So this is for standard deviation. So let's see if its mode is there. Mode. So we don't have anything. NumPy does not have an attribute mode for it. Okay. Then we have a numpy.random method. So it returns the random. NumPy has a random. It returns the random value. So we have So this one, numpy.random.rand size returns the value between 0 to 1 random distribution. So I'm writing 5 comma 2 is the size of the array which I want, and it will give values between random values between uniform distribution 0 and 1 is not included. So np dot random, so this is the uniform distribution. I will write 2 into 2. So it will return value four values distributed between 0 and 1 is not included. So 4 values. Okay. Then we have random n. So it returns random value of standard normal distribution. This was uniform distribution, and we have standard uniform distribution. Okay. So this will return 3 into 2, 6 values. And what if I wrote 2 here? So it returned 2 values. Okay. And if I wrote 2 comma 2, it will return 4 values, random values between standard normal distribution. This is the uniform distribution. This is standard normal distribution. Then we have random numpy.random.rand integer, which contains low, high, which can be none, and then size is equal to none. So this return the values between now size is 10. So the size 10 means 10 values between 0 and 5. Random integer between 0 and 5, and 5 is not included. So I'll use this example only. So what is happening if I'm not writing any, if I'm giving only single integer, so it will take from 0 to 5 and 5 is not included, so it will give till 4. So random 10 values. You can see here the answer is different, 0, 0, 2, 4. Here answer is different. We have 3 zeros, 3 fours, okay, 1, 1. Here we have 2 1, we have 2 2 here, no 3, but 3 is here, so it gives random values. If I would have written 1 comma 5, so it would have started from 1 till 5. 5 is not included, so 1 comma 4. Then this is same 2 comma 8, showing the low and high, and size is 10. And this is the size 10, size is in form of a tuple, which is a 2D array. So if I write 1 comma 51, and size I will write in a form of a tuple, so 3 comma 3 comma 3. So it will return 3 into 3 matrix with random values between 1 comma 50. So this is the answer. Okay, then we have numpy.random.random sample or numpy.random.ranf, which gives the same answer, which gives the random float with half of an interval. So half open interval, which means random float number between 0 comma 1. 1 is not included, and it's in a form of a continuous uniform distribution. Okay, so both gives the same answer. So I will only give you one example, np.random.random sample. So here's the answer 5, distributed between 0.0 to 0.1, and 1 is not included.